When you divide a polynomial by a monomial, it's important for you to remember to divide everything in this polynomial by the monomial that you have on the end. Now, sometimes you'll see the problems written like this, but other times you'll see them written out as like a fraction. So you'll have your polynomial as the numerator and the monomial as the denominator. What we want to remember to do is we want to make sure that when we divide this, that each term in that polynomial gets divided by that denominator. Okay? And sometimes if you think of it like this, it gets a little confusing. So when I do these problems, what I like to do is I like to rewrite it so that each term in my polynomial becomes its own fraction with the denominator of this monomial. So my 6x squared I'm going to divide by 2x. And then I'm going to take this 20x and also divide that by 2x. Okay, so I'm just going to take each term in my polynomial and divide it by the monomial. Now when I do this, it's easy because I can just use what I know about dividing monomials. I'm going to divide my number. 6 divided by 2 will give me 3. And then when I look at my x's, I have 2 x's on the top and 1 x on the bottom. If I go to simplify these, I can cancel out 1 x in the top and the bottom, and that'll just leave me with 1 x up top. My second term, okay, this 20x divided by 2x, I'm going to still leave this subtraction sign here. Same thing, 20 divided by 2 is going to give me 10. I have 1x on the top and 1x on the bottom. Those will cancel out. So my answer to this problem is just 3x minus 10. Now this works for all kinds of polynomials, whether they're simple or more complex. So here, 2x cubed plus 12x squared minus 8x divided by 2x. I want to think of this as just dividing every single term on the top by 2x. Okay, and the way I do that, like I said, is I kind of set them up as individual fractions. So now let's look at this. 2x cubed divided by 2x. My 2's are going to cancel out. And I have 3 x's on top, 1 on the bottom. So the 1 on the bottom will cancel out one of them on the top, which will still leave me with 2 x's. So that's just going to be x squared for that first term. In the middle, okay, so I have a plus sign. I've got 12 and 2, so 12 divided by 2 is going to give me 6. I have 1 x on the bottom, 2 x's on the top, so they're going to cancel out, and that'll leave me with just 6x. And then finally, if I look at the last term over there, I have negative 8x minus 2, so it's going to be a negative. 8 divided by 2 is 4. And I have 1x on top and 1x on the bottom. They cancel out, so I don't have any x's in my answer. So my answer to this problem is x squared plus 6x minus 4. Now the last type of problem you're going to see, same idea, except for the fact that we might get an answer that looks a little weird. When you divide these polynomials, there's no guarantee that the answer you get is going to be really nice and pretty. Sometimes you're going to get things that look a little strange. So again, I'm going to take this monomial right here, this 3y, and I'm going to divide each term by 3y. Okay, so I just rewrite all these problems, and then we're going to go through and simplify. So if I look at this 4 and this 3, I can't do anything with it. Okay, those numbers can't be simplified, but I know I can simplify my y's. I have 1y on the bottom and 2 on the top, so the 1 on the bottom cancels out 1 on the top, and that still leaves me with 1 on the top. Middle, I have a negative sign, and then I'm going to look at these fractions. I have a 6 and a 3. Both of those have a factor of 3, so I'm going to take it out and be left with just a 2. 1y on the top and 1y on the bottom cancel out, so in the middle, all I have left is just a 2. And then finally, for this last term, it's got a plus there. My 3's will cancel out, give me just 1's, but I still have this y on the bottom. So it's going to be 1 over y. So now look at this answer. This one looks really strange. It's 4y over 3 minus 2 plus 1 over y. And I leave my answer just like that because I don't have anything that can be combined. I don't have any like terms. I don't have a common denominator. So this is my answer, even though it looks like I must have done something wrong.